Welcome back. Today we've got with us Jan Stryjak, Associate Director with Counterpoint Research, to talk to us about NB-IoT. Thank you for being here, Jan.
Thank you. Good to be here.
Tell us more about NB-IoT and why it's the leading tech when it comes to both low-power wide area applications as well as 5G massive machine-type communications. What are the key drivers behind this adoption?
Okay, so the first driver to mention is probably the benefits of cellular LPWA over non-cellular IoT. So licensed technologies such as NB-IoT and LTE-M use existing cellular infrastructure, which means instant standard-driven deployments, global scale and interoperability, robust security, and platform integration synergies for operators. Also, 3GPP-based cellular technologies benefit or enjoy ecosystem-level benefits thanks to tighter partnerships between components, devices, infrastructures, operators, and cloud vendors. And this all means that the adoption of cellular LPWA technologies can scale much faster than siloed proprietary LPWA offerings. The second driver is NB-IoT's importance in 5G developments. So NB-IoT has been endorsed by the ITU as a 5G standard, and as it is mainly based on LTE, it can smoothly evolve as a key feature of 5G NR. So this means that NB-IoT will be a top choice for massive IoT deployments in the 5G era. But it's not just about 5G. So 2G migration will be a major catalyst in driving NB-IoT uptake. So around 100 operators around the world have already announced the shutdown of 2G and 3G networks. And by freeing up spectrum resources from 2G and migrating to NB-IoT, operators can reduce operating costs and significantly improve spectrum efficiency. And this can therefore increase the number of M2M connections. And then the final driver I want to mention is the benefits of NB-IoT technology itself. So NB-IoT provides superior power consumption, coverage, and building penetration compared to 2G M2M, and has lower module costs, improved coverage, greater energy efficiency, and wider spectrum support compared to fellow licensed LPWA technology, LTE-M.
So sounds like a leading technology indeed with a lot of potential. But like all these developments, I mean, there are misconceptions. Tell us about some common ones.
Okay, so the biggest misconception is probably that NB-IoT is not fit for mobile applications. Now, yes, NB-IoT was initially best suited for simple, fixed, passive, sensor-based applications, but 3GPP release 14 greatly improved the technology's mobility, coverage, and positional accuracy. And as a result, NB-IoT now supports seamless mobile communication use cases such as asset tracking, logistics, pet tracking, that kind of stuff. The second myth is that NB-IoT data rates are inadequate for IoT deployments. Now, NB-IoT is specifically designed for smaller data packet transmission. Now, that makes it perfectly suited for use cases that don't need a continuous stream of data. This also makes NB-IoT modules very energy efficient and cheap to make, and provides good building penetration for indoor use cases. Then, there are probably a few things that might need clarifying. So first, NB-IoT can use eSIM or iSIM, so embedded SIMs, integrated SIMs, as well as classic plastic SIMs, depending on the module design. And then also, NB-IoT does support firmware over-the-air updates, since it has a reliable downlink channel. But like all LWA technologies, the related energy consumption must be considered, especially if it's a battery-powered application.
So if this NB-IoT is being adopted around the world, tell us from a network and an ecosystem perspective, what's the latest rundown on the adoption process?
Okay, so the NB-IoT ecosystem is thriving, and recently there has been rapid growth in industry activity and interest. So there are hundreds of companies are increasingly active across all aspects of the NB-IoT value chain, from components and devices, modules, through to platforms and analytics. Now, while some companies prefer to focus on one particular segment, so like operators and connectivity, for example, I'll get to that in a minute, but others such as Cisco, Huawei, Telit, and Thales are active across multiple segments. So from a connectivity perspective, which is the crux of the NB-IoT value chain, really, there are currently around 106 live NB-IoT networks globally. Now, these are mostly in Europe and Asia Pacific, but it's quickly expanding into other regions, Americas, Middle East, and Africa. As for revenue, the highest value segments of the NB-IoT ecosystem, and therefore the most likely sources of future revenue growth, are platforms and analytics. And we think service providers should therefore look to expand beyond simple connectivity and into these high value areas. So in terms of adoption, global NB-IoT connections reached 186 million by the end of 2020. And as the number of use cases grows, and due to increasing operator launches and module shipments, connections are growing rapidly. So we at Counterpoint Research forecast just over 1.2 billion NB-IoT connections globally by 2025. And this is just over a third of the cellular IoT total.
So out of all of these millions of connections, tell us some success stories that we can learn from.
Okay, so NB-IoT applications can be divided into four broad categories. There's smart cities, there's consumer, industry, and agriculture. So I'll give an example of each maybe. So smart metering is a key smart city application for NB-IoT, which aims to simplify utilities management. So as an example, Vodafone UK has developed a NB-IoT-based system to save water loss to leaks. Now, anyone who lives here in the UK may know that our water network is incredibly wasteful. Around a quarter of water that runs through underground pipes is lost due to leaks. So this project's aim is to reduce this wastage by 15% by 2025 and to halve it by 2045. Now, within the consumer kind of bracket, consumer applications include things like smart or connected appliances. And as an example, China Telecom has signed contracts with 12 top home appliance manufacturers and has deployed more than 300,000 smart shared appliances across China. As an example, the 5G-enabled air conditioner in shared accommodation provides a centralized control function, which saves around 25 million kilowatt hours of electricity each year. Now, within industry, there's smart logistics is one of the big ones. So systems that track a product's location and transport conditions. So Deutsche Telekom's Roam-B is such a system. So sensors, or Bs as they're called, are added to goods or vehicles, and they measure the exact location and environment of what's being transported. So things like temperature, humidity, movement, things like that. And then lastly, within agriculture, there's one example is smart poultry by Axiata in Indonesia, which increases the efficiency and effectiveness of poultry farm management. So the system monitors environmental conditions in real time and tracks feed efficiency, measures quantity and weight of chickens and things like that. So the applications are so broad, but there's so many great use cases.
In one line, what's so great about NB-IoT?
We are already at 186 million NB-IoT connections globally, and we forecast there to be 1.2 billion by 2025, which will account for just over a third of the cellular IoT total. Thanks to easy deployment on existing networks and smooth evolution to 5G, NB-IoT sets the foundation for 5G massive machine-type communication. So fast-growing NB-IoT applications transform people's lives, which benefits society and the economy as a whole.
So with all those applications, from the cities we live in, our homes, all the way to the food we eat, NB-IoT is changing our lives every day. And thank you, Jan, for coming today and showing us more about that.